Hi, today we are going to learn about multiple linear regression. As you know, the assumption is that there is a linear relationship between predictors and the outcome. Here is the general formula for multiple linear regression. So we have the outcome, the constant, coefficients, predictors, and the error. The topics that we are going to cover in this lecture are explanatory versus predictive modeling with regression, feeding a predictive model, evaluating predictive accuracy, selecting a subset of predictors. And the example of prices of Toyota Corolla is going to be used. In the explanatory model, the goal is to explain the relationship between predictors and the target. And the goal of the modeling is to fit the data well and understand the contribution of explanatory variables to the model. The goodness of fit will be evaluated by R-squared, residual analysis, and the p-value. In contrast, in the predictive modeling, the goal is to predict the target value in other data where we have predictive values, but not the target value. And the goal of the model is to optimize the predictive accuracy. So we train the model on training data, and we evaluate the performance on validation data. Remember, explaining the role of the predictors is not the primary purpose here, but it's useful. In the example of prices of Toyota Corolla, the goal is to predict prices of used Toyota Corollas based on their specifications. And for the data set, prices of 1,000 used Toyota Corollas with their specification information will be used. Basically, the first 1,000 cars from the data set will be used. Here is the description of the variables used in the analysis, including the outcomes and all the other variables that are selected. And here is the sample of data set, which has the prices and the selected attributes used for the Toyota example. Price as an outcome, and the rest would be only the selected attributes used for the Toyota. Before using the data, we need to partition the data into training and validation set. 60% for training, 40% for the validation. For the pre-processing data, since the field type predictor is categorical, it must be transformed into dummy variables. There are 3 categories for the field type: petrol, diesel, and CNG. But we only need 2 dummy variables, one for diesel and one for petrol. We don't need to define dummy variables for CNG because if diesel and petrol are both 0, the car must be CNG. So remember, we cannot include all the binary or dummy variables for the regression because this will cause a multi-collinearity error, but it's not a problem for the data mining. Now we are going to fit the multiple linear regression model between the price, which is the outcome, and the other variables, which is the predictors. And we use only training sets, 60% of the data. Since this lecture is being recorded, for the sake of time, please pause the video and practice the code. If you have any error in the code, please ask me in the next session. Before starting to write the code for the feeding a regression model, first we need to import some required functions. And here are those required functions. Now we need to load the data, and then we need to reduce the data frame to the top 1,000 rows and only selected columns for the regression analysis. And then we need to partition the data, 60% for training and 40% for validation. Finally, we print the coefficients and performance measures for the training data. And here's the code for that. Here's the output of the code. As you can see, we have estimated coefficients for the predictors, and we have the accuracy metrics for the regression model. And these are the traditional metrics measured on the training data. Now we use the regression coefficients to predict the prices of individually used Toyota car based on their age, mileage, and fuel type, and so on. And here's the code. And it shows the output for only 20 records. The 20 records. This is the output, and as you can see, the table shows a sample of predicted prices and the errors as relative to the actual price for 20 cars in the validation set using the estimated model. Now the question is, how well did the model do with the validation data? So we need to evaluate the performance of the model based on the validation data. And here is the code. And the output shows the regression statistics in terms of different errors that we learned before, overall measures for predictive accuracy. So these are the errors that we learned before. Now we want to plot the histogram of validation error to see the magnitude of the error. And here's the code, the histogram. As you can see in the output, most of the errors are between minus and plus 2000. Note that this error magnitude might be small as compared to the car price, but it should be taken into account when we are considering the profit. That's a really important point. Well, we fit the model with the selected predictors. Now the question is, can we reduce the number of predictors? So the goal is to find the parsimonious model, which is the simplest model that performs sufficiently well, because the model with less predictors is more robust and has higher predictive accuracy. We will evaluate the predictive accuracy using validation data, remember. And there are two methods for reducing the number of predictors in the model. The first one is exhaustive search. The other one is partial search algorithm. For the partial search algorithm, we have forwarded selection, backward elimination, stepwise regression. In the forward selection, we start with no predictors and then add predictors one by one. For backward elimination, we start with all predictors and then at each step, eliminate the least useful predictors according to statistical significance. Stepwise regression is similar to forward selection, except that at each step, we consider dropping predictors that are not statistically significant, as in backward elimination. So for exhaustive search, all possible subset of predictors will be evaluated, single, pairs, triplets, etc. It's intensive in terms of computation, so it's not feasible for big data. The result will be evaluated by adjusted R-square. And as we can see in the formula, there is a penalty for number of predictors because we want to reduce the number of predictors as much as we can. Here's the code for exhaustive search, in which we will use the exhaustive search function. And the function takes 3 arguments: a list of all features, variable list, a function that creates a model for given set of features, the training model, and a function that scores the model, scoring the model. So we have the training model, the score model, and list of all variables. And here is the rest of the code. Here's the output of the exhaustive search, which shows the best model for each number of predictors. And as you can see, the performance metrics improves as you add predictors up to it. Look at this column, the adjusted R square column. The number of R squared increases until the 8 predictors are used, and then slowly decreases. If you look at the other column, AIC column, it also indicates that the model with 8 predictors is a good model. Another information that we can get is that the dominant predictor in all models is the age of the car with the horsepower, weight, and the mileage playing an important role as well. Because if you count the number of true in each column, you can see as compared to the other predictors, these are, have more number of true in their column. For the backward elimination method, we start with all predictors first, and then eliminate least useful predictors one by one, repeatedly. And then we stop only when all the remaining predictors have statistically significant contributions. So here's the code for backward elimination using AIC. And here's the output for the backward elimination method. We started with all predictors here and kept removing predictors until the point that the score didn't change. So we first removed CC predictor, then met color, door, and after that we stopped because the score didn't change. And we ended up with 8 predictors. As you can see, the chosen 8 predictor model is identical to the best 8 predictor model chosen by the exhaustive search. If you go back and see the result, you can see that. For the forward selection method, we start with no predictors, and then we add them one by one. Basically, we add the one with the largest contributions. We stop when the addition is not statistically significant. So here's the code for the selection method. And here's the output for forward selection method. We started with the age of the car predictor, and we kept adding predictors to the point that the score didn't change. And we ended up with 8 predictors as well. Again, you can see that the chosen 8 predictor model is identical to the best 8 predictor model chosen by the exhaustive search. Here's the code for stepwise regression method, which is similar to the forward selection, except at each step, we consider dropping predictors that are not statistically significant as in backward elimination. And as you can see again, we ended up with 8 predictors, and the chosen 8 predictors in the model is identical to the best 8 predictors model chosen by the exhaustive search. If we compare different methods, you can see that we got the same result for this particular data set, which is not always the case. So using different methods, forward selection, backward elimination, and exhaustive, we can see that, all of them are suggesting the same 8 predictors, but it's not always the case. This is only for this particular data set. So as a summary, today we learned that linear regression models are very popular tools, not only for explanatory modeling, but also for prediction. A good predictive model has high predictive accuracy. Predictive models are fit to the training data, And predictive accuracy is evaluated on separate validation data set. Removing redundant predictors is a key to achieve the predictive accuracy and robustness. And finally, subset selection method help to find the good candidate models, but at the end, we need to run them and evaluate them and select the best one. So that's it for multiple linear regression model. Please practice the code and let me know if you have any questions. Have a good one and bye.